All right. All right, everything looks right. Welcome on in, everybody. We're here for Math 1, right? Math 1 today. It's Thursday. Yeah. So here we go. Going over some interesting stuff today. We're going to look at inequalities and systems of inequalities based on two variables. So you did some inequalities earlier in the semester, but those were like one-dimensional inequalities. Here we're looking at two-dimensional inequalities. And I have to say, I think this is one of the sections where Delta Math they do a number of sections really well. In fact, beating a lot of the much higher priced softwares that we use in other classes, where the students have to actually pay $80 a piece. But this one, I think Delta Math really hits it out of the park. They really do a better job with their problems and explaining this section by far than any other piece of software that I've seen that has similar stuff. It really makes sure that you understand what's going on. So let's get into that. So let's kind of remember, we're going to take a step back. The stuff I'm saying for the next few minutes is going to sound familiar, hopefully, because it's stuff that you have seen before. So I'm kind of taking a step back and reviewing for a few minutes just to get us back up, like thinking about this. We have the right things in our head, the right ideas in our head, so that then when I take the new steps to the new stuff, we're sort of building on those steps we've already taken. So let's recall the equation of a line. So say y equals 2x minus 1. I didn't hit any of the right buttons there. Let's see. Y equals 2x minus 1. So here we have the equation of a line. So let's remember, what is the equation of a line? Well, the equation of a line, although it looks like this solid object, is really a collection of an infinite number of points, each of which represents an ordered pair where you have an x value and a y value, and that x value and y value together are a solution. Oops, let me move this over. In fact, we can do this. A solution to this equation that y equals 2x minus 1. So for instance, let's take the point. Where's a good point here that's easy to see? How about 2, 3? Okay. So the x is 2, the y is 3. If I plug 2 in here for x and 3 in here for y, we get 4 minus 1 equals 3, which is true. And if we take any of these points on the line and plug them in, they will work. Even these ones that have like fractional values, but those get kind of messy, right? So a line is just a visual representation of an infinite number of solutions, and we can see them. Okay. Then we went to systems of equations, and we said, okay, what about y equals negative 2/3 x plus 1, something like that. So now we had two lines, right? Well, if all the points on the blue line are solutions to that, and all the points on the purple line are solutions to that, then the solution to the system, the solution that satisfies both of these equations at the same time, will be the solution to the system of equations. It will satisfy both of these equations, and that lies right here, right? Looks like it's 3/4, comma 1/2. So if you take 3/4, comma 1/2, plug it into either of these equations, it will work. Okay, and we saw there was some kind of weird solutions you could get. Normally it's this, where you get one point of intersection, but you could also have the, the railroad tracks. The two lines are parallel side by side, never intersect, no solution, and you can have the two lines that are right on top of each other for an infinite number of solutions. But most of the time, this is what occurs. You get a point of intersection, that's your solution. You plug it into both of these, they work. You're happy, you've just solved your system of equations, and you can move on. Okay. Today we're moving to inequalities, two-dimensional inequalities, and what do those look like? These get a little bit messier because, first of all, they're really hard to describe the solutions with notation. So that's why we usually end up graphing them, right? Somewhere along the way in your process of doing these problems, you're probably going to do some graphs when you're doing these. Like we saw, you can do systems of equations algebraically. You don't need to look at the graph. But systems of inequalities, you're probably going to have a graph in there somewhere to guide you along. So what happens if I make, let's just mute that one for a minute. What if I make this an inequality? So instead of having an equal sign, we have either a less than, a greater than, a less than equal to, or a greater than equal to. One of those four options. So look what happens when I do that. Oh my gosh, what just happened? It just shaded in half of the screen. What's happening here? Why is that? Notice the line didn't change. Right? This is important to realize when you're constructing these. The line stayed in the same place, but now all of a sudden we shaded in half the plane. So what's going on here? Well, what happens is this inequality means that all of a sudden we have a lot more solutions, because anything that makes this side greater than this y value over here is also a solution. Right? Because you imagine, think about it this way. We have y less than or equal to 2x minus 1. Well, if you're on the line, you're a solution to that equation. So if I plug in something on the line, then y will be less than or equal to 2x minus 1, because we already know that y would be equal to 2x minus 1 if you're right on this line. But what about all these over here, these points? Well, let's plug some in. Let's take a point over there. So, and you'll be doing this in the homework. I really like how Delta Math does this, where you'll be picking points from the region. Some of you down the road, you'll call this region the feasible region, right? We don't really get into optimization in this class, but we can get to the feasible region, where you start optimizing things for your business or research or whatever. But here we're just going to come up with the regions and see what they look like. So how about we take the point 6, 1. Do you see it sitting there? That's in the shaded region, right? So x is 6, y is 1. What if I plug that into my, let's just get rid of that one for now. Let's plug that into my original inequality over here. So if I plug in 6 for x, I get 12 minus 1, which is 11. And I would get 1 for y. So 1 is less than or equal to 11? Yeah, that's true. See how the less than opens it up, so there's a whole lot more solutions than when we just had the equal to part? So all of these things over here become solutions as well. So generally the way we would do this is we would graph it, and then we would shade one side or the other. Now here's the question. How do you know which side you're supposed to shade? Well, I kind of just did it backwards because Desmo shaded it, and then I justified why it shaded this side. You're going to do it the other way around. You're going to have an area that is not shaded. You're going to calculate which side to shade, and then go from there. So, for instance, we just saw that if I put 6, 1 into our equation, or our inequality, that it works. What if I picked a point from over here? Let's try another point. Let's try the point 1, 4. Now look, that point is not in the shaded region. Okay. So what happens if I plug that in here? I put 1 in for x and 4 in for y. So if I put 1 for x, I'd get 2 minus 1 is 1. So that would say that 4 is less than or equal to 1? No, that's not true. That's not true. So what's the pattern that we've seen? If I take a point from this shaded region and I plug the xy into my inequality, it works. It's true. If I take a point from the unshaded region and plug it in here, it doesn't work. We get a false statement. So guess how you're going to figure out which side you're going to shade? You're going to use what we call a test point. Okay, so let's back up now. In fact, let's just create a whole new problem so you can you won't really know what's going to happen, and you'll have to sort of think with me through it to figure out which side we're going to shade. So let's make up y equals 2/3 x plus 5. So here we have this line. You always graph the line. I'm going to make this an inequality in just a minute. I'm going to make this y is less than or equal to 2/3 x plus 5. But I don't want to put it up here yet because it'll shade it, and I don't want to give away which side we're going to shade. I want you to have to kind of follow along what I'm saying and reason with me about which side we're going to shade. So this problem in a moment will become y less than or equal to 2/3 x plus 5. So the first thing you do if you have the inequality y is less than or equal to 2/3 x plus 5 is you graph the line as if it were an equation. Because remember, that's our we call it the boundary condition. This line will separate our solutions from the things that are not solutions, okay? Because remember, this line is equality, and equality gets included in a less than or equal to or a greater than or equal to, okay? So, okay, so let's say I wanted to figure out for y less than or equal to 2/3 x plus 5, which side do I want to shade on? Okay, so remember, we're doing a less than. So here, let's go over here, actually. Let's do it here. So I want y is less than or equal to the fraction 2/3 x plus 5. There we go. Y is less than or equal to 2/3 x plus 5. So the first thing you do, here's your step number 1. Draw the line y equals 2/3 x plus 5. Okay, so that's the first thing, because that's going to separate your solutions from your not solutions. Okay, so we draw that line. We've already done that, because hopefully you remember how to draw a line at this point, right? So y equals 2/3 x plus 5. We've got that. Our next step is to get a test point, because we need to figure out which side we're going to shade on. So you pick a test point. Pick a test point. So what you need to do is pick something that's not on the line. Right? Pick something that's not on the line. Pick something that's clearly on this side or clearly on this side over here. Okay? As long as you don't pick it on the line, you're good to go. So just pick it on one side or the other. So we've 0, 0 is a nice one to pick, because that one's real easy to plug in. You can't do that if the line goes through 0, 0, but in this case it's nice. Let's take 0, 0. But any test point will work as long as it's not on the line. So let's pick a test point. How about we pick 0, 0. Okay, so that gives me an x value of 0, a y value of 0. Now we're going to plug that into our original inequality. So 0 is less than or equal to 2/3. Oops, I have a typo up here, don't I? This should say 2/3 x. Sorry about that. That should be an x up at the top. So it's y less than or equal to 2/3 x plus 5. Somehow my x didn't make it in there. Okay, so that means I'm going to plug in a 0 here plus 5. Okay, so then we have to ask ourselves, is this true? Is 0 less than or equal to 2/3 times 0, which would be 0 plus 5? So is 0 less than 5? Yeah, that's a true statement. In other words, 0, 0 is a solution to this inequality. So therefore, we know everything on the same side of 0, 0. Oops, I can move this so we can kind of see. Everything on the same side of 0, 0, all of this is a solution. So we're going to fill all of this in. And notice that's what it does when I put up the less than here. It fills that side in. So if you take your test point and it works, fill that side in. If you take your test point and it fails, fill the opposite side in. Okay? So that's how it goes with these inequalities. So let's take a look at a homework problem. Right, so here we're going to write a single, oops, I should move this over. Write a single inequality from context. So let's take a look. Okay, so now you have to take a word problem and interpret it in the way we just did. So Anna is working 2 summer jobs, making $11 per hour tutoring and $15 per hour clearing tables. Anna must earn no less than $230 this week. Write an inequality that would represent the possible values for the number of hours tutoring, T, and the number of hours clearing tables, C, that Anna can work in a given week. Okay, so let's see. Okay, so that's a lot of information. So just break it down, right? Whenever you have a math problem that's overwhelming, just break it down into smaller pieces. So let's see. Anna's working 2 jobs. Okay, one she makes $11 an hour, one $15 an hour. She has to make at least $230 per week. Okay, so what would that look like? Well, if T is the number of hours tutoring and she makes $11 an hour, then 11T is the amount of money she makes from tutoring. And C is the number of hours she spends clearing tables, and she makes $15 an hour. So 15C is the amount of money she makes clearing tables. So it makes sense that has to be greater than or equal to 230. When they say earn no less than, then that's the same as greater than or equal to. So that should look like 11T plus 15C. And notice how they give you the buttons down here? Less than, equal to, greater than, equal to. 11T plus 15C, that has to be greater than or equal to 230. There we go. See that? See how that works? All right, let's look at another one. The drama club is selling tickets to their play to raise money for the show's expenses. Each student ticket sells for $7.50 and each adult ticket sells for $11. The drama club must make no less than $990 from ticket sales to cover the show's costs. Write an inequality that could represent the possible values for the number of student tickets sold S and the number of adult tickets sold A that would satisfy the constraint. So again, if you take the number of tickets sold of a certain type times the price of that type of ticket, you get the money generated by that type of ticket. So let's see, if we have 7.5S plus 11A, so that's the amount of money generated by student tickets plus the amount of money generated by adult tickets, that needs to be greater than or equal to 990. Hit submit, yes, and it gets it for you. Also, just so you know, it's fine to hit this, but a lot of times people don't like to always grab for the mouse because it slows you down. You can also do the greater than or equal to by doing the greater than sign and then putting an equal sign after it, and it just makes it greater than equal to. Okay, so it's kind of smart that way. So you can go through and figure this out. See, Caleb has N nickels and D dimes. He has no more than $2 worth of coins altogether. Write the situation in an inequality. Yeah, okay. So it's kind of the same thing. So that is how you take a description, a real world description, and change it into a mathematical inequality. So now let's go back and think about systems of inequalities. Systems of inequalities. We just looked at an inequality separately. Well, what are systems? Excuse me. Sorry, the hiccups are coming back. What would our systems of inequalities look like? Okay, well, let's add another one in here. So y is greater than or equal to negative 4/5 x plus 3. Okay, so what do we have here? We basically have 4 regions because we've got, let's change the colors here so it's a little easier to see. Let's make this one orange and let's make this one blue. Yeah, that's a little easier to see. What do we have here? We have 4 regions, right? Because each of these inequalities splits the plane into 2 regions. Okay, and we can look at them separately. Let's get rid of this one here. Look at that one by itself. We can look at that one by itself, but we put them together. What do we have? We want the solutions to satisfy both of these inequalities. Well, by looking at how you shaded, some of you might already suspect which is the right region. This region over here was never shaded. That means it doesn't satisfy anything. This region up here is shaded only blue. That means it only satisfies this blue inequality. This one down here is just orange. It only satisfies the orange inequality. This one over here was shaded both times. So what does that mean? This region over here satisfies both of these inequalities. So this is actually the only region that should be shaded. It would take me a minute, but I could go through and make it so that the only region shaded is here. But do you get the idea? This should be the only shaded part. So any of these over here, if you take any points over in this right region that's doubly shaded, and you take that point and plug it in, it should satisfy both of these inequalities. Okay, it should satisfy both of them. So that's basically how you do this. Is it's not even more complicated. Like when we did systems of equations, we had to create these whole new complicated systems. With this, you don't do it. You basically you do your first inequality and figure out where to shade that. Then separately, you do the second inequality and figure out where to shade that. And then you just look at both of them together and go, oh, this is the region that got shaded both times. So it's not harder. You're just doing the thing we did a minute ago twice. You just have to do it 2 times, and then you get it. Okay? So this would be the region over here. So let's go back and look at a couple problems. Systems of linear systems graphically. Okay. Solve the following system of inequalities graphically. On the set of axes below, state the coordinates of a point in the solution set. Now remember, there's an infinite number of points in the solution set, so there's not just the one point you're looking for, right? A lot of times when people talk about math, they'll say, well, there's always an exact answer. There's always a right answer. That's not always true. Here there's numerous right answers, right? Which I guess technically you could say there is a right answer because there's many of them. But there's lots of things that will fit down here when you get to the I'm going to have to, let's see if I can shrink this page a little. When you get down here, it's not going to let me fit everything on the screen. See, when you get down here to actually input a point, there's lots of things that are going to work. It's not just only one thing that works. There's numerous things that work. Okay, let me blow it up again so we can see. Okay, so solve the system of inequalities graphically on the set of axes below. Okay. They're putting it in slope-intercept form for you. So hopefully you're comfortable with all that slope-intercept stuff that you can put this together pretty quickly to say, okay, so that would be at -5. Slope of 1 would be that. And then I want to shade aside. Let's see. Let's figure out which one would put in here. If I put in 0, 0, I'd get 0 is greater than 0 minus 5. That's true. So we want to see how I'm changing the shaded side by this button right here. Oh, and I didn't mention this. See how you can change the line? It goes from dotted to straight. What's that about? Actually, we need to. Because see how we were doing examples a moment ago that were greater than or equal to. But this is not greater than or equal to. This is just greater than. What that means is the line itself is no longer solutions. It's the stuff on one side. In that case, we use a dashed line. So if you have the or equal to part, you use a solid line. If it's just a strict inequality, you use the dashed line. Okay, that's how you do that. So this is the shaded region representing the first inequality. All right, now we'll do the second one. So again, slope-intercept form. Right, so I'm going to go to -2, and then my slope is -2. So if I'm here, this says I'm going to go down 2 over 1. There's my line. We want it to be a solid line, so I'm not going to change the solid line. Notice how it gives you this option to switch back and forth between which line you want to work at. So if you need to go back and fix line number 1, you can go back in there and do it. But we want to work on line number 2. The line is right because it's an or equal to, so solid line. But now I have to figure out which side I'm going to shade on. So let's plug in 0, 0. So I'd have 0 is greater than or equal to -2. Yeah. So we want to shade the side that has 0, 0 on it. So again, you can see, oops, I'm going to have to, I guess I'm going to have to shrink it again so we can see it all. Because of where my screen is, I can't fit it all in there. But you can see the regions, right? We've got, this is the points that don't satisfy either one. This area satisfies one equation or inequality. This one satisfies the other. This is the doubly shaded area here, right? So that's where we need to pick a point from. Pick any point you want. How about 1, 1? So if I go in here and I put 1, 1, as my point. Say yes. It goes, great, that works. It's got its own sample point of -3.6, but that's how you'll go through and do that. Okay? Any questions? Are we comfortable with that? Okay, then I will move forward. I'll pick a good size here. Okay, so we do that. Identify point in region of inequalities. We just kind of did that, right? Let me double check what these look like. Yeah, so here's just the shading part. So basically, you're going to figure out the right point. That should be, if you understood what I've said so far, you'll understand that one. Okay, point solving system of inequalities. Oh, same idea. Where's the thing I'm looking for? Oh, system of inequalities word problems. And these are I'm actually going to jump over and do the other ones from context, because actually they'll help you do this. So watch. It's sort of, I think it's a little more informative. Okay. So let's work through this problem. Carter and his children went into a bakery where they sell cupcakes for $3 each and cookies for 50 cents each. Carter has $35 to spend and must buy a minimum of 15 cupcakes and cookies altogether. Right? Apparently there's some hungry people back home. Carter took his children. So apparently he needs to get 15 things for people because there's 15 hungry people, right? So he needs at least 15 things. If X represents the number of cupcakes purchased and Y represents the number of cookies purchased, write and solve the system of inequalities graphically and determine one possible solution. There's more than one possible solution, but they don't all work. So for instance, notice that if he had, what if he just wanted to go in and say, give me 15 cupcakes? Well, cupcakes are $3 each. That would cost $45. He doesn't have enough money for that. So somebody's getting cookies. All right? Some people aren't getting the cupcakes. Someone's getting cookies. So we have to, we have to figure out what are the possible combinations that he can get that can work. They can't be all cupcakes. Could be all cookies, I guess, but then you might have some people complaining. Probably the fairest way to do it. But let's sort of figure this one out. Notice they're forcing you to put things in slope-intercept form. That's okay. Hopefully you're comfortable with that, but it does take a couple extra steps. So you're actually going to see, I'm going to have to write these down because I have to think about it. So let's see. If X represents the number of cookies, the number of cupcakes purchased, and Y represents the number of cookies purchased, write and solve the system of inequalities graphically and determine one possible solution. Okay, so we need to come up with inequalities for this. So one of them, think about the total, right? Any restrictions they give you in the problem will give you an inequality. So let's see. There needs to be a total of 15 things purchased, right? So that would lead us to believe that X plus Y has to be greater than or equal to 15. He can get more than 15 things, but he has to get at least 15 things, right? So does that make sense? That's our first inequality. Also notice it's not going to let us write that in here. They want it in slope-intercept form. So let's put that in slope-intercept form. Y is greater than or equal to 15 minus X. So all I did was subtract X from both sides. All I did was subtract X from both sides. Now I've got what I want. Now we're going to write this in delta math. So we need the greater than or equal to and then 15 minus X. So greater than or equal to 15 minus X. We plot it. Now we have to figure out which side to shade. So which is this? This is the, take a test point basically. Let's pick 0, 0. Is 0 plus 0 greater than or equal to 15? No. So this 0, 0 point right here, you can't quite, am I going to be able to get it on screen? Darn it. Just a little, what if I do this? Nope. That's not going to work. Guess I'll have to shrink it down again. It's just a bummer when I shrink it down because then you can't see stuff as much. 0, 0 is right in the corner. We tried that. It didn't work, which would mean we don't shade this side. We'd shade the opposite side, this one. So like that. That's the correct side to be shading. Okay. All right, now let's go back. I'll change the size so we can see as we're doing this. But okay, what's the other thing? Oh, the price we haven't taken into account the price restraint. So 50 cents for cookies, $3 for cupcakes, has to be less than $35. And what is X is the number of cupcakes? Okay, so that tells us then X is the number of cupcakes, and those sell for $3. So 3X is the amount of money it's going to cost to buy the cupcakes, plus 0.5, that's the cost of cookies, and Y is cookies. So that's 0.5Y is the money it costs to buy the cookies. That has to be less than or equal to $35. Okay, so there's our second inequality. But again, it's not in the right form. We need these things to be in slope-intercept form, and it isn't. Okay, so let's see. What are we going to do to get it in the right form? First thing I do is probably just multiply everything by 2. 6x plus y is less than or equal to 70. I just multiplied the whole thing by 2 just to get rid of that decimal. And then now I can subtract 6x from both sides. So y is less than or equal to 70 minus 6x. Okay, there's our second equation or inequality. So we need a less than and then 70 minus 6x. So I go back here. Now, I'll blow this up so you can see it. It's a greater than. So what you do is click this and say we want less than or equal to. And what was it? 70 minus 6x. 70 minus 6x. Now I'm going to go back and read the problem because it's really easy to forget what was said. So we want to make sure that it doesn't say less than when we're assuming it says less than or equal to. So let me just reread the problem and make sure the way I was thinking about it is right. Carter and his children went into a bakery where they sell cupcakes for $3 each and cookies for $15. Carter has $35 to spend and must buy a minimum of 15 cookies. Yeah, okay, that all seems right. So let's plot it. Made it too big. Okay, so you can see how these lines overlap, and then we have to think about which side of this line are we supposed to shade on. Well, let's try 0, 0. So let's go back here. If I put in 0 is less than or equal to 70 minus 0, yeah, that's true. So we're going to shade the side that has 0, 0 on it. So that means we're going to shade that side. Okay. So now when it says we want to find solutions that we can plug in here for what Carter could buy this many cupcakes and this many cookies, take it from the doubly shaded region, which is this one right here. So if we zoom in a bit, we can actually see it again, except we can't actually see it because the problem's too big. This is kind of a pain. Let's see. Oh, there we go. The key is to make it super small. Okay, that works. Guess it can be this big maybe. Okay, so if we go in here, we need a point in here. So how about 5, 15? That would be this point right where the cursor is pointing. That should work. So let's see if we do 5, 15. Now that's not the only choice. I could have gone over here and picked 525 or 530, or how about 340 or 150. There's lots of different combinations that work. So that's why there's more than one down here. So if you're saying, wait, where did he get that point 515? It's just any point that's inside this doubly shaded region. So I hit submit, hit yes, and it says, yeah, there you go. Okay, so see how we did that? So there's a bunch of steps here, but they're not actually terribly difficult. It's just remembering how everything fits together. It's actually just like that basic thing that we did at the beginning of class where we graphed an inequality. We're going to do it twice, and we're going to look for the doubly shaded region, pull a point out of there, and put it in the answer. Okay? Yeah, if you and there's other answers. He could buy 5 cupcakes and 30 cookies. If he was just like, man, I don't want to leave this bakery with any money in my pocket, he could just spend all his money and get a lot more cookies, right? Get a lot more stuff. Okay, let's see. Let's go back. Where are we? Let's try a level 2 problem. Okay, so here, now we start to get intimidated, right? Oh, man, there's 3 inequalities in this one. Oh, man, how is that supposed to work? You just do the same thing 3 times. So remember how the last time I was just explaining how it's 1 step, but you do it twice? Here it's 1 step, but you do it thrice, right? You do it 3 times. So Evelyn has X quarters and Y dimes, having no less than 16 coins worth a maximum of $3 combined. At least 4 of the coins are quarters. Solve the system of inequalities graphically and determine one possible solution. So there may be more than one possible solution, but we're going to figure out at least one. Okay, so X quarters and Y dimes. So 1 should be pretty straightforward. We've got, she has at least 4 quarters, and X is quarters, so that means X has to be greater than or equal to 4. Right? So we plot that. Remember, that gives us a vertical line. So that's going to tell us that it has to be to the right of this line. So when I switch it, right, how do I know that? Well, this one is so basic, you don't even have to, I mean, you could plot a point if you want. Just pick a point and plug it in, but it's only the X value that matters. So your X value has to be greater than or equal to 4. If that makes sense, you don't even have to use a test point for this particular one. We will for these other ones. Okay, so we've got that. All right. Evelyn has X quarters and Y dimes having no less than 16 coins. Okay, so that means her total coins has to be at least 16. So now we'll just go over here. That means that X plus Y has to be greater than or equal to 16. Meaning that Y should be greater than or equal to 16 minus X. So Y has to be greater than or equal to 16 minus X. So Y is greater than or equal to 16 minus X, and we plot that. And now we have to figure out again, which side do I do it on? How about 0, 0? We'll pick 0, 0. Plug it in here. Is 0 greater than or equal to 16 minus 0? No. So we want to shade that side, not the side that was 0, 0. 0, 0 was our test point, led us to a false answer, so we're going to shade this side over here. Okay? Now is the one that takes a little bit more work, because we're going to have to think about dollar value amounts. So she can't have, let's see, a maximum of $3. A maximum of $3. So each quarter she has, we multiply by 0.25. Each dime she has, we multiply by 0.1. And that's going to give us the value of her coins. So that's going to be what? 0.25x plus 0.1 Y must be, what did it say, a maximum of $3? Must be less than or equal to 3. Is that right? Let's see if I did that right. A maximum of $3. Okay, so everything has to be less than or equal to 3. So here's her money from quarters. Here's her money from dimes. Has to be less than or equal to 3. Okay, so in order to solve this, why don't we just multiply everything by 4? So that's going to give us, actually, we're going to have to multiply everything by 10, aren't we? Yeah, so let's multiply everything by 10. So that's going to be 2.5x plus y is less than or equal to 30. So I multiplied that whole inequality by 10 in order to get rid of the decimals. Just going to make it a lot easier to deal with. Now I subtract 2.5x from both sides. Y is less than or equal to 2.5x. Sorry, 30 minus 2.5x. Y is less than or equal to 30 minus 2.5x. So let's put that one in there. So y is less than or equal to 30 minus 2.5x. Plot that. And then now we have to figure out which side to shade that on. What if we plug in 0, 0? Is 0 less than or equal to 30 minus 0? Yeah. So we're going to shade that side. So now it starts to get a little confusing because you have a lot of colors here. But it looks like this is the region that's shaded all 3 times, this triangle right here. So that means we need to pick a value in there. Let's see. Am I thinking about this right? Yeah, that should be the one that's shaded all 3 times. So that could be like what? That could be 6, 12. So let's see. If she has 6 quarters and 12 dimes. Now before I answer it, let's just see if I'm right. Is this possible? If she has 6 quarters and 12 dimes, that means she has, nope, that's wrong. Oh, having no less than 16 coins. Right. So she has 18 coins. If she has 6 quarters and 12 dimes, she has 18 coins. Good. Worth a maximum of $3. So what would this be? 6 quarters would give us $1.50. 12 dimes would give us $1.20. Add those together, that's less than $3. Good. And she has at least 4 quarters. Yep, looks like it satisfies everything, right? And you can pick other points in there that will satisfy it as well. So I hit submit, yes, and we're good to go. Okay, we get our solution there. See how that works? Oh, they kind of did it in pieces, but see how they went through and picked out the values right there. Okay. Now in this case, it's kind of interesting. Only the corners of the grids actually can work because you can't have like half a quarter. You can't have 2/3 of a dime. But in some cases, if it's like money being used, you could because you're going to have like, you know, it depends. Depends on the type of problem you're doing. The fraction of values might make sense. Depends on what your problem represents. Okay, what are you representing? All right, are there any questions on doing that one? How we did that? And then once you do that, then, you know, your system of inequality word problems, you're just sort of doing it, but without the picture. Sort of the picture is not involved in that case, okay? So that's how you do those types of problems. And then next time we'll start getting to work on polynomials. And then remember, once we get through polynomials, basic polynomials, let's see, that should be when we have the test, right? So, wait, when did I say the test was? Oh, that would be after this chapter. I was thinking we had one more chapter to go. But we don't. Polynomials comes after that. Okay, so let me talk about the test for a few minutes. Here's how this will work. We will have the test basically about a week from now. So early next week, I will release a practice test for you. Okay, you'll have the practice test, and then you'll have a few days to work on that. Then you're going to want to bring questions to the review. So we'll have a review day, but it has to be driven by questions that students have. Otherwise, I'm just guessing at what you want to see, and then I don't really know. So if you send me screenshots of homework problems, I can prepare those to go over. If you have questions from the practice test, we can go over those. You'll have a few days to do a practice test. And then at the end of next week, you'll have a window which you can take the test. Okay, and the test is not short. You'll have, it shouldn't take you terribly long to do, but the test window is pretty big. So that means you're not rushed. It's not like, some teachers, they want to do make it really hard to do a test. I just want you to have time so that you can casually work through it. You're not stressed. You're not freaking out. You're just working through the thing, getting it done, and then you'll take the test. And then even if you do really bad on that test, there will be a retake exam the following week after that, so you can get that done. Okay, so so don't panic on the test. Do your best and try to be prepared for it, because it's great if you don't have to do a retake. You don't have to do extra studying and stuff like that. But it's there for you in case you do poorly, in case things don't go well as well as you'd want them to do. Okay, so early next week I'll post this practice exam. We'll talk about it and we'll look things over and go over it, and then we'll prepare for it. Then you'll have the actual test. So that will all be next week, okay? And I'll actually put in a discussion board where people you guys can talk to each other about the test. Okay? Are there any questions on the test? Like how any of that's going to work? We'll go over details on Monday, or Tuesday, I guess. But if you have any questions, let me know. No? Okay, then anyone who wants to talk to me, jump into Zoom, and we can discuss anything class-related that you want to discuss, or school-related, or whatever. Otherwise, have a good weekend. Try to get your homework completed. That's going to help you prepare for that test. Go back and look at stuff you haven't done for, 6 weeks. Just look at it real quick. Remind yourself how it works. You go, okay, that's right. That's how I do those problems. And you'll be all, should be ready to go for the practice test and stuff. Okay? All right. Thanks, everybody. I'll see you next week.